Welcome all. Let's design of circular column. So column is circular in shape. They provided the diameter of the circular 300 mm. Diameter of the circular column is 300 mm. Unsupported length 3 meter. Column braced against side sway. Materials is provided M20 grade of concrete. So that is FCK 20 Newton per mm square. Tensile stress steel is provided 415 Newton per mm square, and factor load is provided 1500 kilonewton. So for the conditions we have to design the circular column. Let's go for a step number 2, slenderness ratio. So L by D ratio, since it is a circular in column, we consider the diameter. So L is 3003 meters, so 3000 divided by D is 300, which is 10, so it is less than 12. So if it is less than 12 means we consider as it is a short column. Step number 3, minimum eccentricity. So L by 500 plus D by 30, which is equal to 3000 divided by 500 plus 300 plus divided by 30, which is 16 mm. So it is less than 20 mm. Also we have to check 0.05 D. It should be less than E minimum. So 0.05 times of 300, which is 15 mm. So it is less than the minimum eccentricity E minimum. So let's go for a longitudinal reinforcement. The formula is PU 0.4 FCK AG plus 0.67 FI AS. So substitute all the values here. So since they provided the ultimate load only, so directly we substitute 1500 into 10 to the power of 3 equal to 0.4 into 20 into AG is your circular in shape. So substitute in pi d square by 4 formula. So pi by 4 into 300 square plus 0.67 into Fi 415 into AS. So after solving the equations, we got the AS value is 3361 mm square. And also check AST minimum 0.8% of area. So 0.8 divided by 100 into pi by 4 into 300 square, which is equal to 565 mm square. So we provided 6 numbers of 28 mm dia bar which satisfy the 3696 mm square. I provided here directly 28 mm. We have to provide from the smaller diameter itself for the trial and error. So finally we will check the minimum AST required value. So it's a AST provided greater than the AST required, hence it is satisfied. AST provided is 3696 whereas AST required 3361. So we provide more than the AST required, so hence it is satisfied. Step number 5, lateral ties. So lateral ties 1 by 4 of diameter of the main reinforcement. So our main reinforcement is 28 mm. So 1 by 4 of 28, which is equal to 7 mm. So we have to provide at least 8 mm dia bar. So provide 8 mm dia bar. So pitch. So pitch is among the 4 conditions. We have to find it out which is the least value. So least lateral dimension, since it is a circular, we maintain 300 mm. Then 16 times of 28 mm dia bar, so 448 mm. 48 times of 8 mm dia bar, that is 384 mm. Then last condition, it should not greater than 300 mm. So these two is satisfied. So pitch is maintained as 300 mm spacing. So let's see the diagram. So this is our 300 mm dia bar dia column, 300 mm dia column. So 300 mm dia column. So we having a 6 numbers of 28 mm dia bars as a main reinforcement we provided. Then lateral ties we have to provide 8 mm dia bar, 300 mm center to center spacing. In case of, if you see from the side view, the main reinforcement is here, then lateral ties is this, the spacing between lateral ties is the pitch 300 mm. So this is the 8 mm dia bar, this is, so this one 28 mm dia bar. So this is the, when we see from the cross sections.